It's life, Jim, but not as we know it. Not as we know it. Not as we know it. It's life, Jim, but not as we know it. Not as we know it, Captain. We'll talk today about what people are saying about Venus lately. Um, it's a beautiful planet. It's, I know it's in a bad section of town, but really, with a little bit of help and maybe some civic pride, it could be turned to, it could be polluted just as bad as the Earth in time. So, let's talk about Venus for a moment. First, they found a putrescine, right? They found one of the remnants of rotting processes on the Earth. And that is our most ready explanation for how that forms, that chemical. And now they found an amino acid precursor, which means a very simplified building block of protein. Very ultra simplified. And we find things like this elsewhere. So I'm going to talk about what this means for a moment. A lot of scientists buy into an idea that isn't really science. It's more of a little bit of fun with numbers, called PanSpermia. And no, that isn't a Boy Scout survival meal. Panspermia is the idea that life forms somewhere else and then gradually rains down somehow, rides meteors, rides comets, whatever. And that life on Earth is not random, other than part of, whenever Earth was struck by whatever bombardment contained life, and that there will be inevitably life on Mars, life on any rocky body that has any kind of gaseous material around it. You know, any suitable environment will not only receive but support life. As our means of detecting the chemicals necessary for life, and by inference all chemicals, improves vis-a-vis our view of the sky and deep space, the more we find all the chemicals that we associate with life: oxygen, carbon, hydrogen. Those are the big ones, but there are others. You can find ammonia, you can find methane, you can find all kinds of simple compounds that are very well associated with life in one way or another. Almost anywhere you look, if you have a glowing incandescent cloud of gas somewhere in the universe, you can take a spectroscope to it and say, hey, look, there's oxygen, there's hydrogen. There's a little lithium too, but I don't think we can get out there in time. You know, whatever elements are created by whatever stellar processes will be found distributed in the various dust clouds of space, which aren't a huge component of space. The amount of dust in space that we talk about, where all stars come from and where all life must come from, is teeny weeny 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 compared to the amount of space that it floats around in. This is important to my feeling about panspermia, because we're talking about numerical probabilities here in models that have not ever been fully fleshed and are not good science in any way, shape, or form. Just ideas of speculation. But when a person calls himself, or the media calls someone, an exobiologist, then suddenly this utter fun speculation, which has no scientific basis, and no models that can be tested, and no experimentation that can be reproduced, is being touted as science itself. You scientists should look at this very carefully before you buy into the idea, because you are basically saying, hey, I'm just an idiot too, if you buy into something like this. I have reasons for why I think so. And reasons why I want to give you an idea as to where I think life might have originated. Distinctly different from either scientific or religious narratives that are popular at this time. So, panspermia. somewhere out in the cosmos where the general density of materials is so vague that tenuous that there's barely any chance at all of a hydrogen atom and an oxygen atom coming into contact with each other over the whole age of the universe. That's how big the spaces are and how small the amount of total material is. And then, say you got lucky, and out of all the potential collections, some of them were hydrogen and oxygen did happen instead of like, right? And so you go to hydroxyl. And then maybe you catch another oxygen, but wait, you have to go through the same number of collision potentials for failure and success again to get that second one. And you have to look at that one that you've got already as an anomaly across the whole spectrum that you have to test again, because it may not be the one that gets to touch another one. It may just, that's it for you, bye. It has no predilection. It has no mandate. It's just one of those random particles that may or may not collide with another one over the age of the universe. So, further, we declare that the places where this does happen, where the material clumps together enough to create more complex materials, more complex compounds, methane and ammonia and other, things that can be created, butane and propane and all kinds of things that are fun, are around forming stars. You get a new formed star. Well, it's created itself on what seems to be inside a big cloud of gas and dust, right? It's pulled a bunch of it together until it's so dense that it has started to fuse hydrogen. And that fusion of hydrogen creates both heat, which is infrared light, and visible light eventually. Generally, stars begin as very dark objects surrounded by deep dust clouds. I think they're called Haro-Harbig objects. And they are already fusing, but the light coming through that dust is not visible light, it's infrared light. We detect that as heat. You can feel it off a fire, that's infrared. The light off a fire is not the infrared. We're seeing higher frequencies there. They don't carry the same amounts of heat, and they aren't producing the same volume. So, you've got a hydroxyl. Over a course of, I don't know how many more potential collisions or misses, it comes in contact with another oxygen atom. Now, or another hydrogen atom, sorry. Now you have water. But it's the only water, because now to do anything else, you have to go through all those mega googles of potential collisions or failures again in this tiny, tenuous, this enormous, tenuous environment where things have basically no chance to bump into each other. And again, and again, and again, and again, and again, and again. And every time this particular particle out of all these specks has to be successful, or else the whole process has to start over again, if it ever starts. And so, to create something that we could consider contiguous to life, in other words, so lifelike that we could argue it, I think it'd have to be more complex than a virus, because a virus only reproduces. A virus doesn't consume. A virus doesn't affect its environment in any way. It only affects its, well, let me put it this way. A virus does not affect its environment in terms of consuming, processing, and discharging chemicals for the maintenance of energy and either motility or reproductive ability. Viruses don't defend themselves, they don't react to stimuli, except the injection stimuli. They have no other purpose. They're not live. So to concentrate something, all those potential collisions, to the point where you have all these replicative proteins that are all identical, right, around a virus, and then you have this like little strand of this like amazing chemical called RNA, ribonucleic acid, which is a communication thing that says, hey, you should do this. That's the orders that, say, a brain sent orders out to a machine. RNA is the orders being sent out. So to do that, to create a virus even, which isn't life yet, as I pointed out, would require so many endless septillions and nonillions of potential yes instead of no. Because only occasionally does it even matter if yes is good the second time, because it may just be the first thing starting again. And whatever your particle is, no matter how complex it's getting, it still has to go through that whole routine of statistical probability. Will it ever find another particle out there? And then, will it be the right one? And if not, the whole process has to start over again. And so, there's not enough time in the universe for that to have happened enough time to form a single-celled organism. Not yet. Not with all the material that we consider to be hadronic material. What we consider or baryonic material is real stuff. There's not enough of it. It's not dense enough in the universe. And the amount of time present for the cold chemistry version of this to take place, in other words, out in the vastness and the ices of the comets and all that, to randomly somehow, I don't know, is impossible over the course of the universe as it is now estimated, 13.7 billion years, something like that. So that sort of prediction is specious nonsense. It's scientific people having fun reading an Archie comic and then thinking that the world is like Riverdale High, and it's not. Archie was gay. For you guys that don't know that, this may be important to you. Archie was safe. That's why Veronica and Betty could like him. So anyway. Oh, the creator gave a tell-all interview, which you should look up. It's very interesting. It's not like involved or anything, but he sort of comes clean, and says, hey. So anyway, who cared? I read Archie comics anyway. I wouldn't have cared either way. So all these things have to happen way too many times for this to happen, for there to be life, for there to be even a virus. The number of atoms that would have to collide with one another to create a virus, because nothing at the viral level is looking to create life. It's not struggling to assemble itself. It has to happen by accident. Absolute random accident. 60 billion atoms have to come together. Absolute random accident. Or whatever it is it's probably not 60 billion, whatever it is in a virus. It's a lot of atoms. Just to make all those proteins. And that piece of RNA. It's a lot of atoms. So to do that, for one virus, there isn't enough time in the universe. And the matter in the universe isn't concentrated enough to make it happen quicker. So it can only happen in the planetary disks, in the protoplanetary disks that stars create as they're first supposed to be forming, right? Out of sublimated gas, they condense. A star gets condensed enough, fusion happens, it starts radiating greater radiation pressure than the gravity against it. It holds itself out like a balloon full of air, just on the radiation pressure of the fusing hydrogen given off. And then that radiates further and pushes away a lot of the dust. When much of what they call dust in astronomy is really just light elements, hydrogen, helium. They call it dust because what else are you going to call it? It's not space, so it's something else. It's dust. So anyway, they push it away. In the time that the new star pushes that stuff away out of its area, other clumps and eddies of material have formed inside that protoplanetary disk and the cloud that the whole star formed out of in the first place. And those, theoretically, after a process of throwing each other around gravitationally, and you're out, that kind of stuff, become a planetary system around a star. Well, that star also has things that didn't become planets, asteroids, comets. Comets are supposed to come from additional shells of material way outside of where the star can push it away with radiation pressure, or melt it away, make it sublime like frozen oxygen would. So what you have there is you have the ingredients for life being pushed away into the cold areas where the comets are and whatnot. Because in toward the inner parts of the solar system, the energy is too high for cold chemistry. And out there, where the cold chemistry is pretty far from the sun. So there isn't really much of an energy source or anything. It just has to happen. And what you're saying happens for panspermia is in these chunks of ice that were unformed planets or comets or whatever the heck they were, that this cold chemistry that bounces one atom off another or misses, oh, look, oh, it's going to work, oh, that happens. Where in the most inert environment impossible, you're saying that active chemistry still takes place. Okay, and yeah, random solar photons do ionize things even out there. And a lot of those objects seem to be burnt. The red gunk that covers them seems to be burnt from the sun or something. But anyway, what it looks like is you don't have enough time for that cold chemistry to do that work. And even when it does, there's no guarantee that that first little connection is going to be turned into a second one and a third and a fourth and a fifth. And that means you have to do the whole calculation over again. The whole model has to be run again to see if it happened a second time. And that whole model has to be run again. Not centered on the one, but centered on your entire universe sample to see if that happened another time, another time, another time. Because when you focus on one object, you say, yes, it's going to happen, just a matter of when. You have to focus on the whole universe, where that's just one of many objects. And it may not. It may go right off your screen, you never see it again. So, my opinion is that panspermia is impossible. That the place that it has to be pushed out to happen is a place where there's too low energy for the things taking place that is claimed takes place. The things taking place that are claimed to take place, excuse me. And I would say that if you're going to look for chemistry creating life and not any specific impetus, not aliens or, some other force. And God is an alien. I hate to say this. For those of you that believe in the Judeo-Islamic Christian God, in whatever form, I had a Baptist minister's son explain the truth to me, and it was kind of scary. Bill, in the Christian cosmogony, in the Jewish cosmogony, and the Islamic cosmogony, did God create the universe? Yeah. Did God create Earth? Yeah. But God was before the Earth. Yeah. So God's a space alien. Well, wow. How about that, huh? So, if you believe that random science, just something happened that there is no possibility, and it's so infinitesimal it's only a statistical anomaly in any decent model that life could ever have formed in the manner that I just described. Or you believe that an alien came and did something, whatever that was, you are, right, doing the same thing. You are basing your thought on the power of your conviction, and that's part of what makes you beautiful. But not on logic, because there isn't enough data for logic. For the authenticity of God's creation of the earth and the world, we have a few ancient scriptures that were written by men who were men in societies of men, whose kingdom was being destroyed and attacked from without, and who had a lot of apocalyptic literature, some of which has not stood the test of time well. However, we also have other cultures that have gods, creators, urges, demiurges, that are considered to have created the universe or the world, or in the case of some of the religions, come to the world and modified it to their pleasure. The Japanese, Amaterasu, right? Her family came to Earth from the stars. Space aliens. Expect to see a mecha anime about it soon. But these views have the same amount of validity as panspermia. if you want to form life through random chemistry, you're not going to do it in the ultra cold outer reaches of the solar system. It's not going to happen in a cloud before the star comes alight, so to speak. Stars don't burn. They fuse hydrogen and create byproducts and release enormous amounts of binding energy. That's what they do. It's not burning anything, unless you put your hand on it. You know. So you're going to have to look somewhere else for the formation of life. And my idea for the formation of life, pursuant to this discussion, is at variance with the creationists and the evolutionists, which you guys that predict life can happen everywhere. You're solid in the evolutionary camp. Matter of fact, you're their fringe element. I'm right smack dab in the middle, because I don't believe it happens either way. I believe in a God, and I believe that God has interaction with the mortal world, and I believe that humans are part of that interaction, but I'm not going to lay down on having been there to watch the universe come to be. I wasn't there. I don't know of anybody who was, and none of those scriptures are from somebody who was. They were all written down by men. The only ones that were ever written down by a God that I know of were the ones that Moses dashed at the feet of the Israelites when he realized that they had fallen into the, having a lot of fun instead of being stoic and pious. And he went back up on the mountain and then had to carve them himself again. So the tablets that are in the Ark of the Covenant are not the ones that God carved. Those are the ones that Moses carved. At least I think so. If I'm wrong, you scholars, please do correct me on this. But the point being, I don't really think we have a very accurate report from any of the gods in their own words where the universe, where the world, where life comes from. We have ideas that are based on a philosophical conviction that some people call religion, that there are greater creatures than we are, that have powers that are beyond ours, that have interacted and so created in some way or can be attributed to the evolution or the creation of man as a very unusual ape. We're the strangest ape there is. I hold out hope for the mandrill, though. Man, nothing like a face like those males and an ass like those women have, huh? And more colors than are in a box of Lucky Charms. So anyway, I want to look somewhere else. I'm not going to look for a supernaturally superior being for my argument as to where life might come from pursuant to this discussion. I am not going to look at PanSpermia, which is the idea that life occurs under cold chemistry conditions in a very rarefied environment where the chance of any collisions at all are infinitesimal, and you have to postulate nonillions of collisions for anything reasonable or useful to happen. And that's just not enough time in the universe. As for the religious conviction, there's not much I can say about it. I wasn't there. I didn't walk with Jesus. I didn't walk with Muhammad. I didn't walk with, who's the old guy, Drona, right, in the Venice. So anyway, I'm going to look at the bottom of the ocean. Earth is a dynamic place. You may ascribe that to whatever you want. The fact that we are still cooling down from our formation, which was as a molten ball in the midst of space, and that this is just residual energy left over, and that as we contracted, the crust split into its sections now, and we call that plate tectonics, the actions of the inner parts of the world with the outer part that we sit on. It's called plate tectonics. Now, however you believe that occurred, either by divine intervention or the divine hand creation, or by random chemistry, or randomization across the universe is very vast, and or in my case, that it is concentrated chemistry, warm chemistry rather than cold chemistry. It's up to you, because there's no final definition in yet. Science can't prove where life came from. Haven't yet. No science has created life in a laboratory. Look how indicative this process is. Yeah, it sure is. So now do it 29 million times and then 29 million times in a random sampling again to see if that one works with the next one or if those two never see each other and life doesn't happen. Yeah. So I think that what we're looking for is we're looking for the bottom of the ocean because the Earth is still putting out, as I just pointed out, a lot of heat. Call it what you will. Tidal forces from the sun and Jupiter, compression, heat from the Earth slowly cooling creates more heat as the pressure on the inner parts increases. You choose. My thought is that there are vast deposits of radioactive material still underneath the crust, and that these have localized hotspots where they've concentrated. These localized hotspots create the magma pockets and the lakes and the magma oceans from which we derive both tectonic activity and some volcanism. Just personal opinion. But you look at all the bismuth and all the lead, well, those things don't happen easily. But uranium does. It's a natural process, it looks like, and lead and bismuth are byproducts of uranium. So that means all the lead and all the bismuth were once uranium. How much uranium is that? I think these are things that people either are not considering or that I'm just spouting spurious nonsense. I don't think so, but, you know, if somebody knows better, I'd sure like to hear from them. So here you go. I believe what we're looking for is we're looking for a place where the minerals and the materials around which life is wrapped, and also the high energy needed for the number of collisions, the number of interactions, whatever it's going to be, possible to take place over such a short period of time as the age of the universe, will be found at the bottom of the sea. And we have what's called thermal vents, geothermal vents, at the bottom of the sea. Places, usually along the tectonic plate divides, where where water is being subducted and then superheated against one of those magma reservoirs I was telling you about, however they form, and then blown back up again, either by breaking through small cracks in the rock or just jetting up through a single hole in the rock somewhere. And you form this chimney because there's so much minerals dissolved in super hot water that as it leaves the opening, the minerals start to fall down, and you build your own volcano, just like you would in the real world, except these are materials that are sifting out of a supersaturated solution of water instead of air. Air supersaturates awful easy. Water takes more. So anyway, what you get what kind of looks like a volcano at the bottom of the sea, or a big crack, but generally with mineral deposits all around it. And this hugely hot water, sometimes as hot, I think, as 900 degrees centigrade. That's hot enough to melt metal. They can't move the remote operated vehicles that they use to observe these things close enough to get really good pictures, because it's so hot it will melt their drones. Think about that. So that's hot chemistry. It's not super hot chemistry. It's not chemistry on the surface of stars, 3,000 degrees, 3,000 kelvins. So a lot more, 3,500 centigrade. So, oh no, I'm wrong. It should be less centigrade, right? I'm not good with conversions there. But at any rate, 3,000 kelvins at least on a star, and that means we're not going to get any kind of chemistry that holds together that we call life in a place like that. But here, just about 1,000 C, we're going to find places where that chemistry can take place. Yeah. That chemistry that is more similar to the so-called reducing environment where life was supposed to begin on Earth. That was the original idea. Remember when they used to run lightning bolts through a UV light ball with various kinds of hydrocarbons in it to see if they could get a homunculus. That's what they were doing. A bacterium! We've done it! Ah, it's alive! It's alive! Ah! How many movies? So, and sadly, for science, And also for moviegoers, that doesn't happen much. Anyway, if you look at these black smokers, though, you find every single condition for panspermia taking place on Earthia, not panspermia. Not out in the cold chemistry regions, but in the hot chemistry regions, where you magnify by multiplying the number of potential collisions and potential bindings that take place in an area that's much more energetic and has distinctive zones where that energy is at discrete levels. Yeah. Because 5 feet, let's say 1.2 meters, 1.4 meters from the opening of a black smoker, if you're not right in the blast, well, it's only 400 centigrade. And about 1.5 meters away, it's about 200 centigrade. And you know, before long, it's only the boiling point of water. And before long, it's, warm day at the beach. So there are temperature regions where the minerals are still intensely highly concentrated, still suffusing the water in amazing amounts. Super concentration, super saturation, unlike anything that could possibly happen in a molecular cloud, where the particles are so tenuous that they barely interact with one another at all. You almost have to postulate dark matter to make them stick together, especially in the face of star radiation. So reflection nebulae should push themselves away, right? Anyway, my point is that you are more likely to find the zone in which life can occur and the materials balance from which you can create that life, from which that life can amalgamate, can manifest, right? No matter who's pulling switches, pushing buttons, pointing holy fingers, or waiting for something to happen because he's got nothing else to do. You're going to find that at a black smoker. You're not going to find that out in space somewhere that isn't under huge heat and huge pressure from the terrestrial point of view, but mild heat and mild pressure from the cosmic point of view. So that's my rebuff, of panspermia as an idea, as a concept, as a hypothesis, because it certainly couldn't be a theory. Well, Bill, if you want to know where life came from, look at the bottom of the ocean, where all the conditions exist, not just a few, and where the time involved is very much telescoped in the positive direction, shortened rather than extended like it would be in cold chemistry.